Hello everyone, I'm Kang Byung-woo, who is in charge of static analysis and MISRA rules. So I'm in the VC software infrastructure team. So I'm going to tell you the static analysis and MISRA rules. So which is the VC software quality index. So we have to focus on our quality. So next. Here is the contents of the table. So the first one is the importance of software quality. So these days, there are lots of cars has lots of software. So because of software is large, so there are lots of aspects or possibility to make it defect. So we have to take care of what the software. And secondly, the VC static analysis and MISRA process. So our OEMs such as Volkswagen and GM, they need to, they ask us, what process do you have and what process do you guys really obey? So I'm gonna tell you VC static analysis and MISRA process. And the third one is the static analysis MISRA rule. What the MISRA rule and what the static analysis is. So we're gonna talk about deeply for this chapter. And lastly, we have the tool which is called Coverity. And so this tool is not kind, it's very hard to use. So we have to learn about the way to use the Coverity tools through the demo. So these are course learning objectives. So as I told you, the first one is importance of software quality and the process and static analysis and MISRA rules and how to use the Coverity tool. The first chapter is the importance of software quality. So understand why software is becoming more important in vehicle and the importance of software quality through example. So okay, this is why software is becoming more important in vehicles. This chapter. So let's talk about electrical system expansion. Car software is bigger than Facebook or OS Windows Vista, as you can see in the graph. Modern high-end car has largest scale of software size, more than Facebook and Windows Vista. And high-end car contains close to 100 million lines of code in 70 to 100 ECUs from IEEE Spectrum 2009. Surprisingly, in 1977, GM's Oldsmobile Tornado is a very old car, but in that year, the car has already 50,000 lines of code per one ECU. It's very surprise thing. I've never thought about that, but in the past, there are lots of software a car has. So these are the video of 2018 Audi A8 drive and traffic jam assist and pilot parking first look. So look at this video and what the technology in here, and let's play. So it is surprising that this technology has already been used in real life. You don't have to drive when you're in the traffic jam, so you just put on or you just turn on the traffic jam assist when you have the Audi A8. Or you don't have to care about what size of your parking lot. You just turn on the parking assistant and just try this technology. You don't have to care about the parking lot size. So these are electronic control unit is expected to play a major role. So until 1980s, electronic components accounted for only 3%. But nowadays, electronic components account for 40%. In conclusion, the proportion of automotive electrical components will gradually increase. So until 98, electronic parts, just stereo or air conditioner or wiper, just put on the wiper, turn on the wiper or turn on the ramp. Until 2005, electronic part has peripheral function. So the electronic part has the 20% of the portion of function, so such as anti-brake system. It is a system that prevents the wheel from being locked during rapid brake. Nowadays, modern high-end car has auto drive and collision control and telematics. So in this technology, we have already developed from LGE, so such as ADAS or GM telematics products. So among the function of the vehicle, the electrical and electronic control section start with an auxiliary function. However, it is expected to gradually perform beyond its peripheral functions. Here is the architecture and functional complexity is increasing. For example, Volkswagen Phaeton. This is the high-end car manufactured by Volkswagen. So in this car, there are more than 10,000 electrical parts in total. So these electronic parts communicate with the other part. So they sharing approximately 2,500 signals. In this signal, there are 250 CAN messages. So the key is that the car is no longer a machine, but an electronic product. These are the trends in automotive competition, so estimated revenues and market share. Prior to speaking, this is the estimation about revenues and market share. The three automotive electronic technologies will occupy equally. So revenue, market share, annual growth rate is 24.3%. So in all three areas, LG is making products. So we have to make it more reliable when making products. So we have safety, such as telematics product, and autonomous driving, autopilot mode, or anything else. We have already developed by ADAS engineering division. And connectivity service, we have connectivity engineering department. So they developed the connected service. This is the end of module, so see you next module. Thank you. Let's start fundamental test engineering. Let's take a quick look about fundamental test engineering. So, what is software quality? The first is that quality means meeting requirements. Therefore, our product should be made to meet customers' requirements. And another meaning is before customer use. So if the customer doesn't want to use when you take a shower, you don't have to use what else? Car. You don't have to use the car when you take a shower. I'm sorry, but the third meaning is operation as expected and managed. So when we make it the product and when we ship it to the customer, and the operation is correctly working. But if it doesn't work, you have to, or a customer have to repair this product. But it's very hard. If the product is very hard to repair, it costs very large. It's very expensive to repair. So we have to consist about the maintainability. So these pictures are example of the software quality. So the main goal is we have to make it this product required by our customer. Customer really already need this product, but somebody's just made this product, so it's nonsense. And what is the cost of quality? So there are 4 types of cost of quality. So first one is prevention cost. Prevention cost is amount spent for our activity to prevent poor quality in products before the product is actually built. So for example, related to development, acquiring tools, and training workers, and planning and establishing procedures. So our step is prevention cost, to prevent the failure or to prevent to repair the product. And the second one is appraisal cost. So amount spent for measuring, evaluating, or auditing product to assure conformance to quality. So such as inspection, testing, and review. So we have the LG make television. So if we ship to customer, we have to audit from the official organization, such as UL or such as CE. So we have to pay them to our product is fit for user or fit for shipping. So these are operational costs. And the third one is internal failure cost. So what the meaning is amount spent to repair failure prior to deliver, such as bug fix or regression testing or rework delayed in deliver. So for example, our company make mobile phone. So the mobile phone come to the field, and if the field issue is occurred, we have to go to the location, such as North America or Europe. We have to make it repair the failure. So this cost we call is internal failure cost. And external failure cost means amount spent to repair failures after deliver, such as customer complaint, warranty repairs, or returns, or product recourse, and loss of customers, loss of reputation, such as this stuff is we call external failure cost. What do you think when is more testing not cost effective? Decide the optimal quality and test level based on the level of risk, including technical safety and business risk and product constraint, such as time and budget. So this graph represents the software quality assurance activity and cost. So these are optimal quality level. So in terms of efficiency, the more you test, the better quality you get is wrong. So you have to decide optimal quality level when you develop the product. And what is testing? This diagram just represent the testing. So you just put the input to the software and observe the output. The observed output should be expected output. So testing is that validate the observed output against the expected output. The rest of sentence are similar in the meaning. So Hazard 1973, testing is the process of establishing confidence that a program or system does what it is supposed to. So the rest of sentence are similar in meaning. Just put the input and observe the output. This is the testing. And testing in V-model. V-model is an extension of the waterfall model, and testing is planned in parallel with each corresponding development stage. So simply, what the V-model means simple. Development and testing are not separate. So at the same time as you develop, this is the developer's life cycle and tester's life cycle. So at the same time as you develop, you have to plan to design your test. So in the requirement phase, you have to plan the acceptance test and test plan and design. And in analysis phase, you have to make system test plan and design. So these are the same design. So please keep in mind, development and testing are not separate. And verification and validation. Let's talk about the difference of the verification and validation. Verification and validation may seem similar but have different meanings. So somebody says what the verification is, that are we building the product the right way? So this meaning is ensure that the product and deliverables correctly meet specified requirements before the testing. So just focus on the process-related activities. Typically will be done through reviews about document and plans and requirement and specification. Just we may perform this verification phase in the development stage. And validation. Somebody say, did we build the right product? So this is the attempt to determine if the system or product meets the customer or client expectation after finishing making the product. And just validation focuses on the product-related activities, and typically will be done through an actual testing. So keep in mind, verification and validation may seem similar, but have different meanings. And test type according to test design techniques. So the first one, these are the 3 design techniques. So specification-based testing, it belongs to black box testing. I'm going to tell what the black box testing is and what the white box testing is. So test cases are derived from functional and non-functional requirement specification. Just we tested using specification document, and so you don't have to know the design or code is required. So just verification about planning the testing. And the next one is structure-based testing. It belongs to white box testing. So knowledge of internal design or code is required because we have to check statement or decision or core tree or architecture. So you have to know the design or code. So with this technique, the extent of coverage of the software can be measured for existing test case, and further test case can be derived to increase coverage. And the last one, experience-based testing. It belongs to black box testing. So the knowledge and experience of people are used to derive the test cases. So my boss has a lot of experience to test. So he or she has a way to test, how to test. He or she knows how to test. So these are the experience-based testing. So black box testing includes the following, such as test case design and based on specification, and the facts can be shown up in behavioral system and functional and non-functional testing. And white box testing includes the following, test case design and based on structure and detecting potential defect in code, and code review, static analysis, and unit test and code coverage. So static analysis belongs to white box testing because we have to know the source code and the architecture. So this module, this is the end of this module. So see you next in the module. Thank you. So the next module is the importance of software quality through the examples. So this is the increasing software defect in vehicle. So software now to blame for 50% of car leakers. This is the graph of software-related vehicle leakers. So almost I don't know how to call this one, but a lot of cars affected by software defects. So nowadays we have to focus on the software defect. So we have to develop the software very carefully. And especially the software defect from network and ECU. So almost 50% defect made by this network and ECU software. There are many defects in the network and the ECU. For example, a BMW recalling 200,000 vehicles for possible airbag defect. So if the car crash to the wall, the airbag sensor doesn't work. So BMW recalling 200,000 vehicles for possible airbag defect. There is a quality problem. So we have to focus on our software quality. These are the examples covered by static analysis. So this is the MP3 player manufactured by Junebug. This is the subsidiary of Microsoft Corporation. So what the defect is, when December 31st, in 2008, all MP3 player of Microsoft Corporation were stopped. So they just look at why the MP3 player stopped. So the question is endless loop issue. So that issue can be easily detected by static analysis tool, but they do not process, or they do have process to static analysis. So damage is customer confidence and reputation for MS has been fallen. And second example is FDA uses Grammatech to analyze liquid medical devices. In the medical devices, they already have the actual problem detected by code sonar. So in United States, they have FDA. So when FDA detecting some software bugs, they use also static analysis tools such as code sonar. So, and the last example is JDK. We also use JDK a lot, but that software also has a bug, about 214 defect among them. So they need to be fixed. And the next one is Toyota sudden unintended acceleration because of MISRA violation. So what the problem is, more than 10,000 lists global variable, and this is not testable, and there is no peer review. So they just has recommended solution such as code review and static analysis to obey the MISRA rules. So if you make the defect or MISRA violation, that can be happen, the accident happen to such as this article. And these are the top costly software bugs. A lot due to a schedule system defect. I'm gonna tell the LA airport flight grounded. That accident is due to a schedule system defect. So LA airport flight grounded, or flight cannot land, cannot take off. So all the planes were unable to take off and land. So all passengers' feet were tied up due to system shutdown. So these are has same things. We have because they lost in money and time and competitiveness and reputation alive. So we have to care about our product when you develop the software. Okay, this is the end of section, and we're gonna talk about the VC static analysis and MISRA process in the next session. Thank you.